Hi, and welcome to my Simhangar. First, I would like to thank all more than 500 subscribers. You really keep me motivated to go on with those videos. Research for the caution panel was quite easy, since Martin Schmidt has some great drawings of it available on his website. Instead of designing everything as one piece, I decided to implement the body as sandwiched layers. Also, the lenses are individual pieces that pop in and out of the body like the real version. The layers themselves are quite simple. The big challenge here was a way to connect them, since there is not enough structure on the front to screw anything to it. So I added a small chamfered slot where I could slide in an additional middle plate to mount everything else to. It has 4 mounting blocks where heat set inserts will be installed. This will be the mounting points for the backplate. This middle plate has to be inserted before mounting the backplate, because sliding it in or out with the protruding LEDs would not work. The final part is the backplate. It is both used to clamp the LED PCB to the middle plate and also to mount the MM5451 LED control board. The lenses are designed very close to the real ones, with a case and a lens cap. I just made the case longer to slide over the LEDs and use the front of it to show the lettering, since I will print it on my glass pad, which is very flat. The caps then just slide onto the case without any glass in them. Before I let my printers go crazy, I wanted to make sure that everything fit as designed. So I printed a lens prototype and a small part of the front. The lens prototype here still has the 2 clips at the back, which I removed later since they broke very easily, and the fit between them and the front has been snug enough. The first plan was to have holes in the middle plate for the clips, but after this test I knew they wouldn't be needed. Since the prototype worked so well, production could start. I printed the cases in transparent PLA on my old Hypercube and the caps in black PLA on my Bamboo P1S. All the lenses got some coats of matte black spray paint and also got tested for any light spills. If light got through, I added more coats of paint and repeated the light test until all lenses were okay. The painted lenses then got placed in a holder so they wouldn't move when the laser did its magic, and added the lettering to the front faces. I printed the front, middle and back plates on my Bamboo, and of course everything got painted black. With all the single parts done, it was assembly time. I'm pretty happy how it turned out. The perf board with the MM5451 is about 20 years old. I built it for version 1 of my simulator. I have a second one which will be used to control the LEDs on the ECM panel. I mounted the board to the backplate so it's easier to find the correct cable length. The LED PCB is nothing special. I used my CNC to cut the shape and drill the holes, but those positions are not very crucial, and everything could easily be done by hand. As you can see on those isolation cuts I did on the bottom right, where the CNC cutter didn't reach the material anymore, it's quite easy to do. Sadly, I don't know the part number of the LEDs I used here anymore, but they are 5mm wide angle LEDs, so similar ones should not be hard to find. Since the MM5451 is a common anode driver chip, I kept the cathode legs of each LED longer to be able to solder them to all the cables that connected to the chip. The anode legs are soldered and then trimmed so they don't interfere anymore. A final test of common connection and proper isolation of each leg is done with the multimeter to prevent the infamous white smoke later. Each cathode leg connects to one separate pin on the chip with a short wire and is isolated with heat shrinking tube so it doesn't touch the 5V plane. The driver chip has 16 outputs on each side. I started to connect only the first half of the LEDs at the beginning. To keep everything modular, I didn't solder the wires directly to the perf board, but used pin connectors on each side. So there's a lot of measuring, cutting, pre-tinning, soldering and heat shrinking to do. The end result is not the prettiest one, but so far it does its job pretty well. Final assembly is not much more than to put the PCB on the middle plate, screw it in place with the back plate and attach the connectors. Of course, I had to run a test program on it. Very satisfying. Maybe you noticed the lower half lights to be a bit darker than the top ones. That's because I messed up the settings for the laser on them, but as always, it's good enough for me. The right auxiliary assembly is a bit challenging with very little space between all the parts. So I installed the Arduino plate with the cabling first and then the instruments one after another. Four 3.5mm wood screws holds the caution panel in place without any problems. It's quite tight in there, but easily enough room to prevent overheating of any component. And it's a really great feeling when all instruments boot up during the build-in test and everything works perfectly. Thanks for watching!